Greetings students. Today we are going to see how to solve the given nonlinear function with inequality constraints using Kuhn-Tucker conditions. Let us see this method through one problem. Take down. Solve z is equal to 3x1 square plus 14x1 x2 minus 8x2 square subject to 3x1 plus 6x2 less than or equal to 72, where x1, x2 greater than or equal to 0. They need not specify the method. If the function is nonlinear and if the constraint is inequality, the method we can use is only KKT conditions. What are the conditions? First, let us know what are the KKT conditions. You have totally 4 conditions. That is, first condition is f is equal to summation lambda I hi. Second condition, lambda I hi is equal to 0. Third condition, hi less than or equal to 0. And fourth condition, lambda I greater than or equal to 0. So these 4 are the general KKT conditions. But each condition will lead to the number of equations that depends on the given number of constraints. Okay, first let us relate the question with the notations we used in the constraints. The question given in terms of z, the nonlinear function given, we take it as f. So from the question, we just rewrite with the usual notation. So let f is equal to 3x1 square plus 14x1 x2 minus 8x2 square. And the subject to constraints are nothing but hi's. So here only one constraint is given, so only h1. What is h1? Is equal to 3x1 plus 6x2 minus 72. So what is the first KKT constraint? Becomes 3x1 square plus 14x1 x2 minus 8x2 square is equal to lambda I hi. Only one h1 here, so only one multiplier lambda 1. Lambda 1 h1. So lambda 1 3x1 plus 6x2 minus 72. If you have two subject to constraints, the right hand side we'll write lambda 1 h1 plus lambda 2 h2. Okay, so this is the first condition. From this, we are going to get number of equations. How? We are going to differentiate this first condition with respect to the unknowns. What are the unknowns here? Number of unknowns, 2, x1 and x2. So differentiate this with respect to x1 as well as with respect to x2. Okay, so differentiating this equation with respect to x1, it is 6x1 plus 14x2. This is constant 0, right hand side with respect to x1. So 3 lambda 1. Writing it precisely, 6x1 plus 14x2 minus 3 lambda 1 is equal to 0. Mark it as equation number 1. Differentiating the first condition with respect to the second unknown x2, it will give you 14x1 minus 16x2 is equal to right hand side 6 lambda 1. That is 14x1 minus 16x2 minus 6 lambda 1 is equal to 0. Mark it as equation number 2. Second condition is lambda I hi is equal to 0. Only one h1 here. So this leads to single equation. Lambda 1 h1 is equal to 0. So lambda 1 h1 is 3x1 plus 6x2 minus 72 is equal to 0. Mark it as equation number 3. Third condition is hi less than or equal to 0. That is only one h here. So h1 less than or equal to 0. Single equation. 3x1 plus 6x2 minus 72 less than or equal to 0. Mark it as equation number 4. And the last condition, lambda I is greater than or equal to 0. Only one lambda here. So lambda 1 greater than or equal to 0. We have to check all these conditions. Okay. So now let us use the equations to find the unknowns x1, x2, lambda 1, and hence simultaneously we'll check the conditions also. So to do so, we are going to divide the problem into the number of cases. The number of cases depends on the number of multipliers we have. If suppose we have 2 multipliers, namely lambda 1, lambda 2, then the cases will be 4. We have to discuss lambda 1 is equal to 0, lambda 2 is equal to 0, one case. So combinations, okay. So we'll be getting 4 cases. But here we have only one multiplier, namely lambda 1. So we'll have only 2 cases. That is lambda 1 is equal to 0. Another case, lambda 1 not equal to 0. Under this case, we are going to discuss what happened to the above equations. Let us see what happens to equation number 1. When lambda 1 is equal to 0, equation 1 becomes 6x1 plus 14x2 is equal to 0. Equation 2 becomes 14x1 minus 16x2 is equal to 0. Okay, so we got system of equations with 2 unknowns. Solving this directly you can solve, or even we can use calculator to solve this. Solving the system of equation, we get x1 is equal to 0, x2 is equal to 0. Okay, so 0, 0 is the solution we have got, which is a trivial solution. Of course, it will satisfy all the conditions. Let us check. Equation number 3 is lambda 1 into 3x1 plus 6x2 minus 72 is equal to 0. Product is 0. Lambda 1 is 0. Means the condition is satisfied. 0 is equal to 0. Equation number 4. 3x1 plus 6x2. If you substitute 0, 0, it will be 0 less than or equal to 72. This condition is also satisfied. Lambda 1 greater than or equal to 0. Yes, it is greater than 0. So that condition is also satisfied. But 0, 0 is the typical solution. Generally, we won't take the 0, 0 solution. Okay, so we'll move to case 2. Lambda 1 not equal to 0 case. Then equation 1 implies 6x1 plus 14x2 minus 3 lambda 1 is equal to 0. Because it's not 0, I'm taking it as such. Equation number 2, 14x1 minus 16x2 minus 6 lambda 1 is equal to 0. Equation number 3, lambda 1 into 3x1 plus 6x2 minus 72 is equal to 0. Product 0, but lambda 1 not equal to 0. Means the function should be 0. 3x1 plus 6x2 minus 72 is equal to 0. We have got 3 equations with 3 unknowns. We can solve it using calculator. Then we'll get x1 is equal to 22, x2 is equal to 1, and lambda 1 is equal to 48.6. Let us see whether this solution satisfies the remaining conditions. Substituting in equation number 4, 3x1 plus 6x2 minus 72. 3x1 plus 6x2 minus 72. Let us see whether it is less than or equal to 0 or not. That is 66 plus 6, 72 minus 72, 0. Yes, it is less than or equal to 0 is the condition. It has equal to 0 we have got. So condition satisfied. Equation number 5, lambda 1 should be greater than or equal to 0. What is lambda 1? 48.6. It is greater than 0. So this condition also satisfied. Yes, so this is non-zero solution. So we consider this as the solution of the given nonlinear equation. Even though you get 0, 0 as the solution, which satisfies all the condition, that is trivial solution. We will not take it. Okay. So now we have got the solution because it satisfies all the KKT conditions. So we can say that 22, 1 is the extreme point of the given function z or f of x. But we should know whether this point is maximum point or minimum point, because in the question they have not specifically given whether it is maximization question or minimization question. In that case, we have to find whether the problem is of maximization or minimization. To check this, to find whether the problem is maximization or minimization type. For that, we have to construct HB, that is bordered Hessian or bounded Hessian matrix. How it is defined as 0 matrix, P matrix, P transpose and Q. Okay. So combination of all these. Let us see one by one what are these. 0 matrix is the matrix with order, square matrix with order equal to the number of subject to constraints. Here, how many subject to constraints are there? We take it as M. M is the number of subject to constraints condition. So here it is 1. So order of 0 matrix is nothing but number of subject to constraints. So here it is 1. So 1 by 1 matrix. What is P? P is nothing but a matrix whose each row is nothing but differentiation of HIs. So P here, dou H1 by dou X1 with respect to the unknowns. Now, how many unknowns here? 2, X1, X2. So, P is nothing but dou H1 by dou X1, dou H2 by dou X2. Okay, so if you have H1 by dou X2. If we have H2, then the second row will be a differentiation of H2 with respect to the unknown. But here we have only 1. So, P is this. Dou H1 by dou X1. What is H1, H2? Already we have taken no only H1 here. H1 is 3x1 plus 6x2 less, minus 72. This is our H1. So dou H1 by dou X1 we will get it as 3. Dou H1 by dou X2 we will get it as 6. Okay. Next P transpose. So first row will become first column. What is Q? Q is nothing but the order of Q depends on the number of unknowns we have. Here there are 2 unknowns x1, x2. So it is 2 by 2 matrix. So how will you find Q? What are the entries? Dou square F by dou x1 square, dou square F by dou x2 square are the diagonals. Then the next entry is dou square F by dou x1, x2, dou square F by dou x2, x1. This is how we'll calculate. What is our F? 3x1 square plus 14x1 x2 minus 8x2 square. From that, find dou F by dou x1 square. What is dou F by dou x1? If you differentiate this with respect to x1, it is 6x1 plus 14x2. So dou F by dou x2, 14x1 minus 16x2. Okay, let us go for the second derivative. Dou square F by dou x1 square. If you differentiate this again with respect to x1, then it is 6. Okay, dou square F by dou x1, dou x2 means dou F by dou x2 we have to differentiate with respect to x1. Then this becomes 14. Next, dou square F by dou x2, dou x1. That is, we have to differentiate dou F by dou x1 with respect to x2. Means it is again 14. Dou square F by dou x2 square. So differentiate dou F by dou x2 with respect to x2. So minus 16. So this is what the bordered or bounded Hessian matrix we have got. So now, the next step is we have to check whether D, that is principal minor of this bordered Hessian matrix turn out to be positive or negative. For that, start with alternate sign plus minus plus. So D is minor is nothing but 0 into the corresponding determinant minus 3 into the corresponding row column. If you delete, the determinant is 3, 14, 6 minus 16 plus 6 into corresponding row column. If you delete, the determinant is 3, 6, 6, 14. Let us check for the sign of this D. So minus 3 into, it is minus 48 minus 84 plus 6 into 42 minus 36. So we can see the sign is going to, because the major thing is positive, so the sign is positive. we don't want exact value of this, only sign we need. So the question, the function is of maximization type if your D coincides with, the sign of D coincides with the sign of -1 power m plus 1. The question is of minimization type if D coincides with the sign of -1 the whole power m. What is m? The number of constants. Yes, very good. Here what is m? 1. Okay. So let us check for the sign of -1 the whole power m plus 1. So -1 the whole power 2, that is plus. So -1 the whole power 1, that is -1. Okay. So here this is positive and this is -1. Okay, -1. And this is negative. So your D coincides with what? With -1 the whole power m plus 1. So we conclude that the question is of maximization type. Okay. Okay, so the problem is of maximization type. So the solution, the extremum we have got is maximum point. So we are going to conclude the question. So the point 22, 1, which we have got is the maximum point, and Z max, the maximum value is substitute in the question. So 3x1 square plus 14x1 x2 minus 8x2 square. Substituting this point, we'll get the maximum of the given nonlinear function. I hope you are clear with this KKT conditions. Okay. Thank you.